Windbreak protection needs past and present. We've talked about the dust and the blowing soil and so forth. We have a lot of other conservation practices that we can use in conjunction with windbreaks to control wind erosion these days. But as I think about the different drought conditions that can occur, conservation tillage or of various sorts, when we try to depend on residue to protect the soil. In drought conditions, sometimes there's not a lot of residue there. So we need to be thinking about how we can protect that soil through a combination of practices of windbreaks and a system approach to provide production agriculture some benefits and conserving our soil. Not only is soil erosion and wind erosion a concern, but also the blizzards that took place as we had snow just this week. But the sudden fear, you can read this as I talk, but dust storms were not the only natural disaster that occurred during that time period. Um, we also had many snow and blizzards conditions where, as you note in this tale that came from a young woman who saved a group of children from a country school. Also, this is back in 1888. At that same time in 1888, that same blizzard that was pretty widespread throughout Nebraska, there were over 230 people that died from that blizzard, including 40 to 100 that were, there were 230 throughout the plains in that area where the blizzard was. About 40 to 100 deaths occurred in Nebraska. People collapsed and died as they were trying to get from their barn back to their house. People would pound pots and pans together, trying to make noise so that they could find their way back to their house. And many of them did not make it. So events somewhat similar to this in 1888, we still see today where we can lose livestock in those kind of conditions. But with a good windbreak, as some of the a couple of video clips pointed out, can provide a lot of protection. We can also have a lot of impact on our buildings and structures from snow. With a well-designed windbreak, you can alleviate some of those same issues. So prior to even going back before the 1930s, as I mentioned, that as settlers started to come to the Great Plains, they were leaving the eastern United States that was primarily heavily forested. So it was a rather big shock to them when they came this direction. But the Timber Culture Act was enacted in 1873, and J. Sterling Morton, who's a name you may recognize as being the founder of Arbor Day and so forth, was the Secretary of Agriculture back at that time period in the 1870s, and he was a strong advocate for this Timber Culture Act. Basically, it's like a homestead act. They could receive 160 acres if they planted initially 40 acres of trees, and they had to maintain that. And after a certain period of time, they had to prove that they did had that many acres of trees planted and they were surviving. 40 acres was a bit of a challenge, as you could about imagine, in some of the conditions that we have in the Great Plains. So it was reduced down to 10 acres. And the example at the bottom is a Norwegian immigrant who settled in eastern North Dakota, not far from Fargo, a little bit north and west of Fargo. He paid $14 his filing fee, and he started to try to plant the 10 acres of trees. He had 675 trees per acre were still alive after 13 years, and he received his patent. So he proved out his claim in 1891. This is a picture of the homestead in 1898. And I just wanted to read his how he certified his tree claim. Good, healthy, thrifty growing trees. Average diameter about 3 inches, about 13 feet tall. Mostly box elder timber trees with a few cottonwood, ash, and oak trees planted to replace a few that died. There are at least 1,610 trees and more to each acre. I know these facts from personally counting the trees and measuring their height and diameter. So it's a labor of love that they put into that, and a lot of backbreaking work, I'm sure, to try and maintain that many trees over the 10-acre area. And this is a hand-drawn sheet of planting guide that he used in designing it. As you'll note that the trees are planted to protect their farmstead, their barns, and so forth. This is a picture of actually the son of Nels back in 1928 and his two sons in front of a rather large tree at that time. After the Timber Culture Act, we recognized that there were probably more failures than there were successes with the Timber Culture Act. So there was a need to try to figure out, well, what is the best way to get trees to grow in the Great Plains? And this started the need for more intensive research in the Great Plains. So there were several research stations set up by the the plant industry department at that time, but what became the Agricultural Research Service. One was in Mandan, and it had a couple of noted foresters on staff, and they worked with a large number of landowners going out by horse and buggy to check on the plantings and work with landowners and trying to establish windbreaks. And over the course of a number of years, they established windbreaks on 1,300 farms in North Dakota, South Dakota, and Wyoming, and Montana. There was a similar station that was set up in Cheyenne, Wyoming, which also served not only Wyoming, but Nebraska, parts of South Dakota, and North Dakota, but mostly South Dakota, Nebraska, and Wyoming. Similar kind of effort there. They planted a host of different species, and a lot of the information that we have today on what species are adapted to conditions in the Great Plains comes out of the work that was done by these early researchers in the early 20th century, and carried on. A lot of it carried on well into the mid part of the century in the 70s and 80s. Unfortunately, most of these stations, a third one was down in Woodward, Oklahoma. They all continued for quite a number of years to provide cooperative work with different landowners, but eventually the funding was curtailed and priorities changed over time, and those programs ended. But the result was that we have a lot of different good information that was provided by their work that they did. We also have to acknowledge that all the land-grant universities in the Great Plains were very active during this time as well, with a variety of different tree and horticultural type research ongoing. Nebraska, South Dakota, North Dakota, and Manhattan, Kansas State were all very active during that period. Maybe not as much in Oklahoma and Texas, but certainly those four land grants were very active during this time frame. As we talked about, the 1930s was a traumatic period of time when the Dust Bowl hit. And there was an effort by Franklin Delano Roosevelt to initiate the Prairie States Forestry Project that ran for 7 years. And they established a large number of trees up and down that corridor, as you see on the map. And it took a lot of effort, a lot of hand labor. There was a lot of hand tree planting that went on, and a lot of hand maintenance that went along with it. They did a rather extensive investigation, you might say, or developed a plan of attack of how they would go about planting these trees. It was run by the U.S. Forest Service, and there was a lot of good publications. They did some research. They examined the different wind directions. You'll see the picture on the lower right is wind roses indicating the wind direction in different parts of the Great Plains, and that's a predecessor of some of the same information that we use today as we design our windbreaks of today. The first Prairie States Prairie State Shelter Belt was planted in Oklahoma. This is a extension agent that helped with planting the first shelter belt in March of 1935. They commented at the time that the established plantings were highly effective at controlling blowing dust and loss of topsoil while protecting crops. The owner of the #1 shelter belt near Magum, the Curtis family, relayed the story that their land was able to produce a crop when others had failed just because of the trees. And that planting is still there well into the late 20th century. As far as I know, it's still there. It's an example of some of the record keeping that they did, the tree planting records that they would use. This is an interesting comment. This is actually it went back and looked at the plantings later and also did replanting. And you'll note at the bottom here, this would have been an ideal plant if the trees would have been cultivated. So That's a pretty common thread that runs through even to this day as far as how well we take care of our tree plantings. Many of those plantings that required a lot of work. There's just kind of interesting historical photos from that time period. I know Pam said she's a windbreak enthusiast, and I wonder how many of these kids that were out there with their hoes were continuing to be windbreak enthusiasts later on. Now, Pam liked hoeing the windbreak. I'm sure there are some of those windbreak haters out there that probably had to sort of set out there to hoe the trees and maybe aren't quite as in love with their windbreaks as Pam is. Thankfully, though, there was mechanization, first with horses, and then finally with some tractors that came along later. They were very successful. This is a forestry foreman examining some cedars and looking for some insects back in 35. And this is, he recognizes Eleanor Roosevelt. Eleanor visited a field windbreak in Reno County, Kansas back in 1939. And she was stated it's very important that school children be given the opportunity to learn all they can about growing trees, since tree growing should be a vital part of all farm operations. This is an interesting example of some more historical archival pictures came out of from Nelide, Nebraska, about 4 miles south. They had a sand blowout, and they went in and planted it with a number of cottonwoods, trying to control that blowout. This is where the counties where Prairie States Forestry Project were authorized. There was some participation. The next picture is a kind of a dot diagram. It's a little hard to make it out, but the different colors are the different years and plantings and locations of where the Prairie States Project shelter belts were planted in Nebraska. So there were a lot of them out there at one time. July 1st of 1942, that project came to an end, was discontinued, and you will recognize that date, 1942. There was something else kind of major going on about that time. We were just getting into the Second World War, so there was a lot of diversion of priorities at that time. So they had the funding and a variety of other things just came to a screeching halt, you might say. The activities were transferred from the Forest Service over to the USDA Soil Conservation Service at that time. SCS was involved in windbreak plantings elsewhere throughout the US at that time, including the Great Plains, in combination with, in addition to what was going on at the Prairie States Forestry Project. But that transfer to SCS had a number of challenges where funding was less, of course, because of the war. There was a lack of labor, again, because of the war. And SCS had a much broader focus. We weren't as single-mindedly looking at windbreaks, and as the Forestry Project, Prairie States Project, was strictly looking at the windbreaks. So without that funding and a central administration, a regional type shelter program just was not possible. At about that same time, Soil Conservation Service started working with soil conservation districts, or the predecessor to the natural resource districts in Nebraska, in trying to work individually with landowners to apply all types of conservation to their land, including windbreaks and shelter belts. South Dakota, in 1943, SCS actually distributed trees free to farmers. I found that interesting, from some of the Forest Service nurseries that were phasing out at the time. So there was a lot of tree stock that was going to be going away. So they had to do something to try to get it distributed as quickly as possible. So they provided the trucks and the staff to help to distribute many thousands of trees across South Dakota. But also, again, that World War II had a big impact on how much was being done. Post-war, through the 1960s, there were more and more soil conservation districts that were formed throughout the Great Plains, and we started to see a pretty marked increase in shelter belt and windbreak plantings during that mid-50s into the mid to late 60s. There's some data there from South Dakota, from conservation district planning that was done during that time period. About the same time, after in the mid 50s, just after the war, I guess 1946, the Great Plains Ag Council was formed. It was a interagency group to look at agricultural problems and issues within the Great Plains. And it was involved Extension Service, Land Grant Universities, Ag Research Service, Forest Service, Soil Conservation Service, state forestry agencies, and a little bit later on, the Canadian provincial government was also involved. As part of that, there was a forestry committee that was set up, and we had there was some great interaction, exchange of technology and so forth across the Great Plains through that forestry committee. So a meeting was held annually. Some symposium were held periodically, like the Shelter Belt Conference in that one in the publication on the right. The information exchange that went on through that Great Plains Forestry Committee, all those meetings, need to be transferred in some fashion to farmers and ranchers. One approach was to develop what we call a tree planting handbook or a thunder book. Some people use that term. The first one was developed up in North and South Dakota, and both North and South Dakota went together to the Soil Conservation Service, the Soil Conservation Districts worked together to develop a handbook on different planting. And that was emulated in later years with a number of other types of books that were developed for other states. This is an example of Arizona and New Mexico, but there's also one developed for Wyoming and Colorado and several others up and down the Great Plains. As I mentioned, weed control has always been a key to make or break the Great Plains windbreaks and shelter belts. With good weed control, there was pretty good success in getting trees planted. Different technology has come along over the course of many years of how to do that. In-row type weeders, both old and new, as well as more recently, the use of geotextile fabric to help control it. There was also recognition that moisture was a limiting factor. In the early 70s, we borrowed some of the technology from Israel. Israel was a leader as far as drip irrigation systems. So there was some work done to modify the designs for more of an establishment. They weren't meant to be irrigated permanently, but they were there to provide moisture in those initial years until the windbreak was well established. Some of that limited moisture also had impact in ag technology. 1960s and 70s, we saw the advent of center pivot irrigation systems throughout the southern and central Great Plains, not as much in the northern Great Plains. But the impact was that that technology was not very friendly to field shelter belts, and they created a lot of conflict with field windbreaks that were in existence. And you'll see in the two pictures that there are some remnants of some old shelter belts, or these are new plantings. This is an example of a planting that was made around the curve in that area between the pivots to try to provide some protection, but it still is a challenging thing to work with. Even some work done to establish small shrub shelter belts, shrub windbreaks underneath the center pivots in some areas. But that was a real challenge. As a result, we saw a pretty large decline in windbreak application and also the loss of windbreaks in the Great Plains, to the point where the General County Office of the U.S. Congress decided that they needed to do a study to find out what was going on with all the removal of trees that were planted back in the 30s with all that input from federal government. So there was some work done. There was a conference held on windbreak management trying to address that. And as a result of that, we did some survey work looking at how much of that resource was still available, how much has been lost. There was a study done in 5 states looking at that. And from 1970 to 75, go on here, running out of time, but at any rate, there was a fairly significant amount of loss in windbreaks. And as a result of that, what came out of that effort was that we started looking at how we could renovate old windbreaks, how we could modify windbreaks and make some changes to them. Prompted another very significant symposium in 1986, International Windbreak Symposium held in Lincoln, Nebraska. Dr. Brandel from University of Nebraska was a key person in getting that international symposium held. It prompted the development of a textbook on windbreak technology, which may or may not be still in print, but is available through library use. But we had representation from 14 different countries, talked about windbreak use being going on around the world. It was a very interesting time to learn about all the different ways that windbreaks are being used. As an outgrowth of that, much like what we're doing here today, is that we needed to transfer that technology that was developed and put in that textbook. How do we put it together and get it out to people like yourselves to help in assisting landowners in applying windbreak technology to their land? So the first short course, which is a predecessor to what we're doing today, was back in 1988. Second one was the following year. Second course of the year later in Bismarck, North Dakota. And I've lost track of how many of these different short courses have been held over the years, but probably in terms of probably 50 or 60 courses have been held since that time period. Windbreak trends, as we had some national resources inventory that SCS and now NRCS does. At one time in 82 and 86, 82 and we actually sampled windbreaks out there. 82 to 92, and we saw that there was a general decline of about 5%. And what happened in the Great Plains? This is some of the information from that 1982 to 1992 NRI, showing that there was a certain amount, between a 2 and 3% loss in windbreaks during that 10-year time period. Today, a little closer to today at least, this is where windbreaks are being applied based on NRCS practice application back in the, you'll see that we're dominant in the northern Great Plains. But as you'll note, there are windbreaks being applied in a lot of other places as well, even in Florida, California, a lot of different applications of windbreaks. This is terms of the miles applied, again, dominated in the northern and central Great Plains. This is from 2006 to 2012, number of feet of field windbreaks, windbreaks in general that have been applied, and you'll see that there's a general downward trend. The red line is the applied. I don't have full data, but this is EQIP, Environmental Quality Incentives Program data from 2012 to 2018. And if we'll back up, you'll see that with the end of 2012, we were down at about, I can't see it this minute, about 5 million. And then in from 2012 to 2018, with using only EQIP, again, stress this is only EQIP, we're in that about 3 million. It's kind of up and down, but about 3 million feet of windbreaks being applied through EQIP. Now, there are other programs out there that can also assist with applying windbreaks as shelter belts, but we're kind of in a steady state, it looks like, as far as application. And again, this is a number of windbreaks from 2007 to 2012, similar kind of decline in trend line. And then when you look at EQIP, again, this is EQIP data from 2012 to 2018. Still, this is the top line is the national number. These 4 lines below are for North Dakota, South Dakota, Nebraska, and Minnesota. And I'll go on to the next slide that shows more detail of those 4 states. As far as EQIP application, those are the top users of, or top application of windbreaks, those 4 states here in the northern Great Plains. Again, we're seeing a trend line, pretty much steady trend line down. It looks like it's stabilized out in the last several years, but we did make a considerable drop from 2012 down to 2014. And I retired in 2013. I'm trying to remember, I think the next farm bill was somewhere in this vicinity. So as you change programs and farm bills and emphasis and priorities, things can really make a difference. This is a little bit of this is some example of a study done that Rich Carmen, who was at the Agroforestry Center, worked with, lost the name, Sarah Kale, and they did a paper looking at Prairie States Forestry projects, Prairie States Forestry shelter belts that were planted in Nebraska, and did a GIS study and looked at what was there. This is a hand-drawn atlas of where the windbreaks were applied. This is a digitized version of that, and then laid it over a photo base to try it, and then they started determining what was remaining of those windbreaks. So as an example, here's one in Antelope County, Nebraska. Here it is in the photo, and it was recorded is a J.W. Spurk shelter belt that was planned in 1937, and it's still present today. And this is a general table showing the status of the shelter belt windbreak prairie states projects in Nebraska from as of 2003 to 2016, based on that photo GIS analysis that was done. Okay, wrap up. So what are the reasons for this decline? Age is obviously the windbreaks. We've got a lot of changes in fields and the types of equipment that are being used. And I think one you'll probably talk more about as over the next couple of weeks are the attitudes towards windbreaks that Pam alluded to earlier. And the question is, can we reverse that trend? There's some options that we can think about. How do we change the attitudes? We are 2 generations removed, at least 2 generations, almost 3 generations removed from the Dust Bowl, and how people are knowing the impacts of what can happen in severe drought. With our changing climate, the role of windbreaks, I think, can have a significant influence as far as adaptation and some mitigation issues due to our changing climate. We're looking at probably less moisture, more drought, more extended drought periods as a result of the changing climate. So windbreaks, I think, can have a pretty active role in that. And how's agriculture itself changing? I think some organic producers, I think this background picture is actually from an organic producer in Nebraska. Maybe not, I can't remember. It looks very similar to one that was that organic producers use windbreaks to try to mitigate some of the issues, help with pollinators and so forth. And the other big question is future government policies and programs. Are they a help or are they a hindrance? Those are all challenges that we're going to have to face. So it's just kind of a little photo gallery going through of examples of different windbreaks from across the country, if they're different, being used for different reasons. Whether it's entire farmsteads, entire towns, screens, living screens, livestock. It's interesting. I was going through some of the equip data. I was surprised how many windbreaks were going in Delaware and Maryland and Virginia. A lot of that is due to poultry production. This is either a combined feeding operation in Minnesota. Living snow fences, we'll talk more about that, I'm sure, later on. But to wrap up, I like this quote from William Blake: "The tree which moves some to tears of joy is in the eyes of others only a green thing which stands in their way." Hopefully there aren't too many green things that are standing in people's way, but it goes back to the adage of planting the right tree in the right place for the right reason. So with that, I know I ran a little long, Pam, but open up for any questions people may have.
Thank you, Bruce. And actually, you had about 2.5 minutes left.
Oh, wow. Okay. That's good for me.
All right. So if you could stop sharing your screen, that would be great. All right. And if you have a question, you can go ahead and put it in the chat, or you can raise your hand and we'll call on you. I have a question for you, Bruce.
Sure.
You didn't talk about CRP.
Uh,
In the heyday of CRP, about how many trees were getting planted through CRP?
I think, the initial CRP, it was pretty low, but when they went to the continuous CRP, continuous enrollment, and what they call the continuous CRP, which included a lot of different buffers, I think we started seeing a lot more windbreak planes going in at that time. I don't have those numbers in front of me, but it was a fairly significant number. Maybe Rich or maybe Craig Stange might have a better feel for that later on, or Craig could chime in now. But there was a pretty strong push in the late 80s, early 90s as we started using buffers, riparian buffers and windbreaks. That was all part of continuous CRP. And there was quite a bit of activity and a lot more planting going on with that. The beauty of the CRP was that they not only got incentives to plant the trees, but they also got a rental payment or a per acre payment, which was a nice enticement for some people. So it worked well in some cases, maybe not so well in others.
Well, it looks like you might get lucky. Oh, Craig Stange,
I knew it.
go ahead and unmute yourself, Craig.
Okay, can you hear me, Pam?
I can hear you, Craig.
Okay. The CRP in North Dakota, that continuous CRP program, was by far the biggest tree planting that we had. It happened to coincide with a living snow fence initiative that we had and some statewide changes to the CRP program that made it a little easier. So I would say probably 70, 80% of our windbreaks went in that 5-year period with continuous CRP. One of the things that made the program more palatable is we took the area between the road and the living snow fence became part of the CRP contract, as well as the trees that were part of the windbreak itself. So that got rid of that tiny little field that complicated farming for many farmers.
Yeah, it's amazing. CRP last year turned 35. And I remember that because it came out the same year my brother was born. So I have to use things to remember dates. And I've been to some of those older CRP plantings and they're doing wonderful. Some of them are still in CRP, some of them aren't in CRP anymore, but we'll see. We'll see what the next farm bill brings, I guess.
Right.
Well, Bruce, thank you so much.
Thank you. And I'll be on the rest of the afternoon. If someone comes up with a question or has another thought, put it in the chat and I can answer it directly or individually.
All right, sounds good. So the next person, we're a little ahead of schedule, which I'm not complaining about. But oops. So the next person to talk is Rich Strait. Rich Strait is with the USDA Agroforestry Center in Lincoln, Nebraska. And his first talk is going to be on windbreak design, or how do windbreaks work? And that's a question I get often as a forester is, how do windbreaks work? And Rich is an engineer at heart. So yeah, I know, Rich. So Rich, take her away.
Well, I'm trying to share my screen. Let's see here. And are you seeing the slideshow?
We can see it, Rich. Looks great.
Okay, very good. Thank you, Ben. Appreciate it. So I'm Rich Strait. I'm in Lincoln, Nebraska, as Pam said, and I'm going to have to take umbrage with that reference to me being an engineer at heart. There's just a long-standing tension between foresters and engineers. So we'll talk later, Pam. So this afternoon, I want to start off. I know people want to get into, tell me how to make a windbreak to protect livestock or to protect living snow fence, protect a road or some specific purpose. But I think we need to step back just a little bit and think about how do the different characteristics of a windbreak help a windbreak achieve the goals we want. So that's what we're going to be talking about. So we're going to start off with some basic definitions and then how the different windbreak design elements influence the wind and the speed and the flow of wind. So there are a lot of different definitions of windbreaks out there. And the one that we're probably most concerned with when it comes to planning conservation windbreaks in Nebraska is, well, what does the 380 standard, the conservation practice standard that NRCS uses, what is that definition? And that's important because most of our conservation programs, be they federal or state or local, often lean back onto the NRCS definitions because of all the work that's gone into them. There's not much reason to really redefine things. And so windbreaks, as you can see, are typically linear in nature, sometimes curvilinear. And we think of them as, because they're planted and just for the practicality of planting, they're in rows. Now, we get stuck in thinking that way, but, and that's just because it's easier to establish a windbreak by planting rows than a more scattered design. Let's see here. Are you getting the presentation mode, or is it still?
You're in outline mode right now, actually, Rich.
There we go.
Yep, there you go. Perfect.
We're back.
Then I want to change to, now are you getting just the presentation mode?
We are getting presentation and a preview of your next slide.
Okay, I don't want that. Now, how about just presentation?
Yep, just presentation.
Thank you, Ben. Appreciate the help.
No problem.
All right. So as we're saying, we often think of windbreaks as tree plantings, but a windbreak by the nature of a wind barrier can really be made of anything, even grass. And as a forester, it hurts to say that, but it's true. Grass can make a wind barrier, but there are also constructed types of wind barriers. And if you want to see some dramatic constructed wind barriers, Google that subject or on some industrial areas, and you'll see 120, 150 foot tall steel fences that are made for windbreaks to protect shipyards and things like that. And that upper left corner picture is actually up at Meade, Nebraska, and that's a research design. So if I ever catch any of you designing windbreak like a tic-tac-toe, we're going to come to blows. That's just not a practical thing. That was for research purposes. And of course, in the lower left, you'll see those constructed slat fences that you'll see often in Wyoming and in Colorado for protecting highways from drifting snow. And so we'll see wind barriers are, we're going to be talking about herbaceous wind barriers, but more woody wind barriers. And again, you can see grass strips, leaving corn strips works fairly effectively for trapping snow and providing some initial protection. But when we look at the 380 standard, and I believe I copied this out of the current version, these are the purposes for which we can use those federal dollars to help a producer landowner to establish a windbreak in the 380. That's a windbreak establishment. And that's quite a variety of purposes there. And just to start off to say, one windbreak design cannot achieve all of those types of purposes. So we want to talk about, well, then how do we custom design for different purposes? Sorry for the background noise. Let's see here. So we first want to think about, well, how will or how can a windbreak provide, or windbreaks provide all those different kind of benefits? Primarily it's because when we change the wind flow, you change the exchange rate between objects. Think of a plant, a crop plant, the soil, livestock, a building, that object. You affect the exchange rate between the surface of that object and the air above it. And that as air moves, that those turbulence, that helps transfer the qualities of that air from one place to another within the current of air. And as these parcels move about, they carry with them those same properties. And you say, well, what properties? Well, just about anything you can measure, those are the properties. We're talking water vapor, heat, and dust, and pollen. And in natural systems, stuff moves from areas of high concentration to areas of low concentration. You know, that's that whole osmosis thing that we talk about in different types of filtering. So as air moves, the stuff that it's carrying with it, or the nature of that air, gets moved as well and gets transferred. And if we can affect the movement of air, we can affect the transfer of those properties. And if you start thinking about it as what you've experienced in the field, as wind velocity reduces, it doesn't have enough energy to carry particulate matter, and particulate matter starts falling out. You'll see the same thing in flowing water. And so the heavier stuff falls out first, and the lighter materials are able to stay in suspension longer with lower wind speeds. And then the windbreak vegetation actually traps particulate matter. It runs into it and it traps it, falls down. And in fact, some of those qualities, think of pesticides and other sorts of things, and chemicals, can actually be absorbed into the plants that are within the windbreak themselves. And some of this wind speed change can actually affect very local micro atmospheric pressure as well. And here's a graph that's a general summary from research on the impacts of reduced wind speed, what it has on these different qualities. And if you look at this graph, the vertical line would be the location of the wind barrier. The wind is blowing from left to right. And then as you move right across the graph, that's further and further away from, or on the downward or leeward side of the windbreak. And you can see that there are changes in crop yield, soil moisture, air temperature, wind speed, and evaporation rates. And so those are the things that we can manipulate as we change the design of the windbreak. So what are we talking about when we're changing the design of the windbreak? Well, it's the physical nature, the makeup of the windbreak. And for as each of those purposes within the 380 standard, if you read the complete standard, then there are additional criteria for livestock protection, additional criteria for energy conservation, additional criteria for whatever purpose. And so in some cases, the designs can be fairly similar, but in other cases, it can be quite different. So we can affect the how the windbreak changes the wind flow and achieve our desired benefits by affecting these qualities of the windbreak. And so we're going to work through each of those here in the next few minutes. So the first one, windbreak height, and excuse me, and that is, when we think of windbreak height, it is the tallest, again, row of trees or shrubs, or the tallest grass in the lower right picture, and the height of that material. And if we're thinking about protecting soil, it's the height above the soil. But if you're talking about protecting a building, it would be the height of the windbreak above the building. And if you're trying to protect that, or the livestock. So a 2-foot grass barrier isn't going to provide much protection for a 3.5-foot tall cow. So you have to be thinking about those relative heights. And you say, well, the trees grow over time if things go well. If we do the weed control that Bruce talked about, trees are going to grow. So, well, what height? Is it the height of planting, or is it the height just before the windbreak falls apart, at its oldest age? Well, it's a very good question. And so what we have to come up with some convention, and for conservation design purposes, we talk about the windbreak height at age 20. Will it grow taller after age 20? Yes, but we had to stop someplace. And if you start talking about windbreak design at age 40, people stop listening to you because 40 is just too darn far into the future. So the windbreak height at age 20 of the tallest species that you're going to put in the windbreak, and it doesn't matter whether that's the windward side of the windbreak, the middle of the windbreak, or the leeward side of the windbreak, it's the tallest row. And it's the average height of that species on that soil on those sites. So there you go. There's H in the grass strip, and there's H with it looks like almost like a poplar there. And that's what we're talking about. And you'll see that referenced fairly often, in that H is the height of the windbreak at age 20 for planning purposes. But if you're going to evaluate an existing windbreak, then you would look at the height of that existing. So what's the big deal about H? Well, the height of the windbreak really affects how far downwind or how far leeward of the windbreak will we experience reduced wind speed? And so you'll see as this graph just shows a 20 versus 40 versus 60-foot tall windbreak. Well, as it's a nice relationship, and the calmest area tends to be within 2 to 5 H of the windbreak. And for conservation planning purposes, we typically look at the distance out to 10 H of the windbreak. And if you remember the graph previously, there is actually a wind speed reduction on the windward or the upwind side of the windbreak as well. For planning purposes, we usually don't claim that, but we talk about up to 10 times the height of the windbreak, even though we can measure wind speed reductions out to 30 times the height of the windbreak. But at that far out, the wind speed reduction is fairly negligible and really doesn't provide much benefit for the producer or the landowner. So that's height. So we can choose species to affect the general or overall height of the windbreak and the area to be protected by the windbreak. The next major criteria or element of the windbreak that we have some management control over is density. And it's probably the most complicated one of all of them actually. And what we need to realize is that wind does not move in a nice uniform sheet, even pattern across and over a windbreak. It's actually rather turbulent. The wind, as it moves around the ends of the windbreak, the wind gets compressed together and actually wind speed can increase as it wraps around the end of a barrier, whether it's a windbreak or a solid wall. And you'll notice this as you come around the edges of buildings or between two buildings, how wind speed can be accelerated. And the wind also, as it's moving from, in this case, left to right, if we're looking right down on top of the wind barrier, the wind blowing into the windbreak directly is affected as it goes over the top of the windbreak and through the windbreak. And the density, overall density of the windbreak will then impact how much the turbulence and the strength and the energy of the wind is reduced. And so we talk about density. And researchers, if you read into research papers on windbreaks, they often talk about porosity. And don't let that throw you. They're just the complementary of each other. So the 60% dense is 40% porous. And so the porosity would be the open space and the density would be the solid material within the windbreak. And typically when we talk about windbreaks, we're talking about the optical density. If we look at a windbreak and we try to look through it, like on that green and white, that's a photo of some trees, and then all the solid was made green and all the open space was made white. And you'll see that that's the optical density. However, the aerodynamic density, or that the wind sees, is not so simple. It is not just go or no go. It's not a binary sort of interplay. And unfortunately for us, we're finding that there is very little direct correlation or uniform correlation between optical density and aerodynamic density. The research into the subject is trying to come up with some ways that we can discover or communicate that relationship. But right now, it's just not a one-to-one or one-to-two sort of relationship. And so we talk about density as its relationship to the porous or the open space. And I should say in this particular picture, that's just within that frame, that's about 40% dense. And it can be very difficult just optically to look at a windbreak and come up with a density. Here are some diagrams. And again, the graphs on the left, 40 to 50% porous is similar to 50 to 60% density. And again, it's the complementary numbers. Here are some diagrams if you wanted to test yourself or test your neighbors on a little windbreak trivia and say, well, how dense are each of these images? and we'll just give you the answers. And you can see that on the lower right, it says it's 55% dense, even with the leaf off on those trees. But if you look, it says there are 7 rows of trees to get that density with leaf off. Whereas in the upper left corner is single row of cottonwood, it's only 20% dense. And so that's density. And as I mentioned, not only is optical and aerodynamic density different, if say on this diagram on the left would be like a slatted snow fence or cribbing fence, or maybe that orange construction barrier that you see that's got the square holes in it. It has very little depth to it. It's mostly height and length. But a windbreak actually has that 3-dimensional quality, and the air just doesn't move straight through it. And in fact, as the air approaches the windbreak and enters into the windbreak, the vector quantities of the energy, it gets broken up and it gets more turbulent, and that's where you get that interaction and exchange of the moisture vapor, the temperature, and those qualities. And if you wanted to have understand why this is difficult to correlate optical versus aerodynamic density, here's the formula that Xinghua Zhou, doing research at the University of Nebraska, came up with to describe that relationship. And you can see it's more complicated than I'm pretty sure any of us on this presentation would want to deal with. So one thing I do want to, I'm going to shift gears now here, and I want to show a short video. So I'm going to see if I can unshare this presentation and shift to another. I'm having trouble figuring out how to unshare this. Help me out, Ben. How do I?
You have it. It looks like, is it a Windows Media file, or is it on your browser?
It's a Windows Media file.
Okay, so you're sharing your desktop right now, so you should be able to click on that, and then it'll pop up.
Well, actually, I was just sharing the file. I wasn't sharing the desktop. So how do I unshare?
Let's see. I'm going to go ahead and pull this back, and then we'll have you reshare.
Thank you. Sorry for this delay.
Oh, no problem. We're all figuring this out as we go along. So
yeah.
Okay.
Thank you very much, Ben. Appreciate it. Okay, now I'm going to then share. There it is. I can find it. Here we go. Share this screen, and I'm going to play this video if I can find out where the play button is again. There it is.
Perfect.
So here's a little project we did. You're seeing the video with the orange smoke, Ben?
Yes, sir.
All right. So this is the upwind side, about 25, 30-mile-an-hour wind that day. And this is the downwind side at that same moment. And you can see that smoke coming up over the top of the windbreak is moving at a pretty good speed. And then you start to see the smoke coming through the windbreak like molasses. And so to understand this, you have fast moving air above the windbreak, and you have slower moving air coming through the windbreak. As you're to move further downwind, eventually, if the wind continues to be unobstructed, that wind starts to meld together, flow together, and will then become one air mass moving at the same rate again. So now, let's see here. Ben, I'm having trouble unsharing again.
Yeah, I'm going to pull this back. And we'll go back to me.
Okay. And I'll go back into, yes. Okay, and then I want to go back to my presentation. I'm going to share, and then I'm going to start it up again. And hopefully you're seeing that formula again.
Yep.
So to recap, you've got the air, some of the air is pushed up and over the windbreak, and some of the air is being forced through the windbreak and around the windbreak. And then as it moves downwind, that air begins to mix again, unless it runs into another windbreak. And so you can see that that slow moving smoke or air moving through the windbreak, that's the desired effect. And it just helps visualize what is going on with the windbreak. And it's not uniform going over, through, or around the windbreak. And so some more information on density. The more dense the windbreak is, the area being protected downwind is shorter. The protection doesn't extend as far, to the same degree, as far downwind with a very dense windbreak. That wind starts to come together much and mix and become more uniform fairly quickly. But with a moderately dense windbreak, say 50%, 60%, the wind speed reduction is extended further downwind before that air begins to coalesce and become a more uniform wind speed at the unobstructed speed. So keeping that in mind, if you want a great deal of wind speed reduction, but you don't need it to be 8, 9, 10 times the height of the windbreak downwind, you want a dense windbreak. If you want a larger area protected, you may not get as much wind speed reduction right next to the windbreak, but you get a greater area of protection with wind speed reduction. You want a moderately dense windbreak. So that's how we can utilize and the effects of change in the density of the windbreak. But density isn't just all that simple, as you can see by these pictures. The picture in the upper left is fairly uniform, whereas the picture in the middle right, it's quite dense down below and it's a little less dense above. And then that lower left picture, I don't know what you want to do with that. It's got gaps, but where there's a tree, it's dense. And so we have to be aware of all these things and how it impacts the wind speed. And on the other hand, we can take advantage of the different densities vertically. And so this graph shows if we have a fairly porous windbreak on the top line, that there isn't much wind speed reduction. In fact, it's almost 80 to 87% of the open field velocity right next to the windbreak. And but in the middle diagram, the windbreak is open on the bottom and dense on top. And so, as you can imagine, that air can flow more easily through the lower portion of the windbreak. And so, yes, the wind speed is actually even greater because that wind gets funneled and accelerated going under the windbreak. And you can see that, however, the change of the wind speed further downwind it's more greatly reduced than the porous windbreak above. And then where you have a moderate density through the entire height of the windbreak on the third line, you can see there's greater wind speed reduction close to the windbreak, and that extends further out into the field. So you can think about density not just as a general characteristic of the whole windbreak, but vertical density as well. And this, of course, would be more easily attained with a single row. You say, well, why would you? Well, we'll get into why would you do that? And you maybe instead of making snow drifts, you want to spread snow and push it across the field. And we'll talk a little bit about that in a later presentation. The next quality of the windbreak that we can affect is the orientation of the windbreak to the wind. But we say, what wind? And, well, we've come up with the phrase, the troublesome wind, the wind that's of most concern for the producer. And it depends on the time of the year and what it is they're trying to protect that may determine which wind direction we are most concerned with. And so as Bruce mentioned earlier, wind rose like a flower rose. So here's a wind rose, and in the resources, I've provided a link for, you can go find the wind roses, and there are several locations in Nebraska, and you can find it for each of the states. They have multiple locations where wind data has been collected since the 30s. in some places just since the 60s. And so when you look at a windrow like this, to look a little more closely, this the upper quadrant, each of those concentric circles are 5%, and the direction then is the compass direction. And then if you look more closely at the bottom part of that windrow's chart, each color represents a different wind speed. And you'll notice that this is meters per second, and I'm not going to convert that to miles per hour on the fly right now. So you'll just have to trust me that it's faster moving when it's the light blue and slower moving when it's black. So there's that website to find a windrows of an area that's close to you. Here's for the month of January at North Platte. The wind direction, they measured at 16 cardinal directions. So north by northwest, northwest, west by northwest, west, that sort of thing. The velocity is indicated by color. The percent of the time that the wind blows from that direction, those are those concentric rings. And then you can come up with the percent of time that it blows from a direction at a certain speed. And for an example, this is Norfolk, Nebraska in January. You can see it's slightly different than North Platte in January. And so if you were to add up the north by northwest, northwest, and west by northwest parts of that diagram, that means that about 39% of the time the wind is from those three directions in the month of January, and then you can see the relative speed. And so here it would be each month for the North Platte, Nebraska, and you can see as the seasons change, so do the predominant wind directions. And we can use that information in our planning purposes. So if you're talking about protecting winter wheat or open soil in the spring or livestock in the winter, you can look at different times of the year. But if you were to talk to the farmer producer, they live out on that land. They're going to know this. They may not know it in a diagram, but they're going to be able to tell you, this is the wind that I'm most concerned about. Well, we all know that wind doesn't always, it isn't just as predictable as we'd like it to be. And that wind does change in directions, and it's not just from one direction. And so how do you contend with that? And often one of the easiest ways is to add a second leg to that windbreak, whether it's an L shape or a U shape, and you can gain additional area of protection, because as that wind comes around the end of a windbreak, it's, as we said, it's compressed and it pulls in. And so the area protected, like on that upper left diagram, it's not a rectangle area of protection, it's a triangle. Or in the lower left, as the wind comes from an angle, you can see how the area of protection shifts with that wind speed. But when you have more than one leg of a windbreak, you get a considerably larger area of protection. So that's one way you can work with that windbreak orientation to the benefit of you, the resource concern or the producer's resource concern. But it's not that way everywhere. Craig Stange and I were up at Billings, Montana, and we saw living snow fences on the south side of a highway. And it just, when you're used to seeing living snow fences on the north or west side of a highway, to see it on the south side of a highway was just very peculiar. But in Billings, Montana, because of geography, a few of things, the wind just about always blows from the southwest. So be aware that sometimes in a particular area or location on a field, that the landform may change how that wind blows, and it's just not the same everywhere. So the next characteristic of the windbreak that we can manage and control is the length of the windbreak. And some of this seems like a sort of duh, that you want the length of the windbreak to be at least as long as the area that you're trying to protect. But it's also important when it gets into aerodynamics and the engineering side of windbreaks, that you need the length of the windbreak to be at least 10 times the height of the windbreak. And that's because, again, the wind gets wrapped around and pulled around the edges of the windbreak. And if you're looking at the, trying to get a good investment on the return of the area protected downwind, and the area protected downwind is dependent on the height, you want to make sure that windbreak is, and I think the research says actually 11 times the height of the windbreak. And again, recognizing that a second leg on a windbreak can be very beneficial. And where you'll see this really show up is with snow and or snow deposition. When the wind wraps around the end of a windbreak, and you can get those drifts that show up around the end of a windbreak. And you'll see drifts around the end of a fence, around the end of a guardrail, drifts around the end of your house, your driveway, around a round bale. You can see these patterns show up. And so that just having the windbreak just as wide as the field of or feedlot that you're trying to protect may not be just wide enough. Here's an example of a house, a little McMansion. And you can see the house was put in, they had a nice, quaint little arced windbreak to protect it from the northwest. And, but if you look more closely, so that's, as the wind would come around that windbreak, there's not much area protected. Plus a 2-story house on those trees is going to be a while. But you can see, they're kind of faint, but if you look more closely, there are additions added to the ends of that windbreak to extend it on either side. My guess is that probably came from experience, saying, you know, we're getting snow drifting right across our long driveway and we're not getting much protection that we'd like. So they extended the windbreak on either side. And with good windbreak design, we can plant it one time rather than keep adding trees to the ends of the windbreak till we find out, you know, where we protect the area that we're trying to protect. One other aspect of the windbreak is continuity. And there's one thing I can say about windbreaks: gaps are bad. You can see in this picture on the right, there's a gap in that herbaceous wind barrier. And what happens? Well, the wind speed is actually increased going through that gap, and it caused desiccation or maybe even blowing soil that abraded or cut off those young emerging plants. So wind can actually accelerate going through a gap. So if you're thinking about replanting in a windbreak, the reason that we emphasize replanting dead trees in a windbreak is as those young seedlings grow, the gap becomes the most harsh place on the farm to grow. We create an accelerated area of desiccation and abrasion. And so before those other seedlings can create this gap, we want to replant in those gaps. And if you're talking about a 1-row windbreak, it's even more crucial. 2 rows, there's a little more leeway. 3 to 5 rows, you don't need necessarily 100% survival. So gaps are a very critical element to avoid. And that works the same for access lanes through windbreaks and the wind direction, if you're talking about drifting of snow or blowing soil drifting through. And the other thing I want to mention on that diagram on the left is sometimes just initially thinking, you say, well, why don't they just alternate? You know, if the first 2 rows are going to be 15 feet apart in the row, and I'll just go every other one. Well, as the wind comes at an angle, it actually can shoot right through that gap very, very easily. So what we often recommend is that if the trees or shrubs that are being planted in adjacent rows require or can grow, can be planted at the same spacing, that we actually make one maybe 15 foot or 16 foot and one at say 12 foot, so that you don't have this opportunity for the trees to line up and create these nice clean gaps for the wind to blow right through the windbreak. So I'm going to be wrapping up here. So when it comes to purpose, the purpose determines the design. And it's what the producer or the landowner wants from the windbreak that determines what kind of windbreak you're going to create. And some programs are geared to address certain concerns, and they may or may not be the concerns of the landowner or the farmer or the rancher. And so there is not just matching the windbreak design, but the program. If you're using cost share dollars, can that program be used to design a windbreak to meet this producer's needs and concerns? And as we understand the location, the site, the resource concern that's being addressed, then we can adjust the height, the density, the length, the orientation of the windbreak on the landscape to meet that landowner's needs and goals. And it can be a very simple goal. This is one of those old 1930-some windbreaks, and handwritten on the back of this photograph is a note that says that this farmer wanted everyone to know that he was only drinking water from that container. He didn't want this picture in posterity to depict anything other than him drinking water. But if you're out there hand hoeing those trees and controlling the weeds, as Bruce was talking about, a nice, cool, shady place to drink a little water can also be a part of that design purpose. The other nice thing about windbreaks, as we said earlier, looking at the 380 standard, is that there are all these different benefits that can be achieved depending on how we design the windbreak. And producers, farmers, ranchers often have more than one need. And we can think about how can we design the windbreak to address more than one need of the producer, of the farmer. They can have aesthetics, they can have wildlife habitat, they could have, maybe they want to harvest fruits and nuts from that windbreak. Maybe they want to increase pollinators for their garden, whatever it might be. And we can take that in consideration and not plan single function windbreaks, but look at ways that we can address more than one resource concern at a time with the producer. So with that, those are some of the mechanics. It is not as simple as I just portrayed. Obviously, as you get into design and you look at the site and the soils, they will put limitations on what your options are. And as you go through the rest of this windbreak short course, we're going to get into more of those issues that play into the decision-making of the design of your windbreak and how to create a windbreak that addresses the landowner's needs and is consistent with the cost share, if you're using cost share, the cost share program that you're dealing with. So with that, I'm going to stop sharing. I think I just stopped sharing.
You did, Rich. Looks good.
How about that? How about that? And let's see here. Did I have my video off that whole time? I apologize. That was not my intent. So if there are any questions, now would be a good time. I will be around.
Comment or a question in the chat that says that they really like the video that you have of the smoke, and I was wondering if that could be used for landowner education or be made available for landowner education.
So yes, there's no copyright, no patent on that video, and I shared that video with Ben and Pam. So Ben, Pam, I'm not sure how you want to distribute it because it's not a small file. I think it's probably too large to email. It's an MP4 file.
Yeah, so Rich, what we can do is, since we've already basically digitized that, we can go ahead and upload it to Google Drive and then provide our attendees with a link where they'll be able to access and download that.
Very good. And actually that video is a little longer, just the portion that I showed to you, and it's got some other good stuff on it that could be quite helpful with training and education. It's a good question.
Well, thank you, Rich. Does anyone have any questions for Rich?
Well, I'm here all week, and as Pam said, tip your waitress. And Pam, do you want to take a break, or do you want to get into the next presentation? How do you want to do this?
Well, let's take a break. I for one could use a little break time. So what we'll do is we'll take a 15-minute break, and we'll start back up. 40, not quite before 3 o'clock, about 2:55.
Very good.
All right. Thanks, guys. Okay, so hopefully we're all back from our break. So I'll introduce Rich Straight again. And Rich, sorry I compared you to an engineer. In forestry school at Mizzou, the foresters and the engineers did not get along.
Well, you and I get along well, so I won't hold it against you, and all is forgiven.
All right, thanks, Rich.
All
So
right.
now Rich will talk about windbreak purpose and also function.
And I'm trying to share my screen. There we go. And come on. So hopefully you're seeing the first slide, windbreak purposes, Nebraska windbreak short course. All right.
Yes, we are.
Thank you. Appreciate the affirmation. So before we get into designing windbreaks for specific purposes, I want to maybe, again, step back one. And windbreaks, we often put in that category of a conservation buffer, very similar to riparian forest buffers or herbaceous barriers or vegetative buffers against streams. And think about what are the role of buffers? Why do we use them? Think about in the context of conservation, some general considerations and the ecological and environmental functions that buffers provide. And I'm not going to spend a lot of time on this, but what we're really doing when we're working with a landowner, producer, farmer, rancher is they have a problem. And so that means they have a desired condition that they would like to achieve. And so then our goal as conservationists are to think about, well, what are the physical processes that need, the ecological functions that need to change to achieve that, and then what buffer practices can we use? And so for an example, if there's wind erosion of soil, we say, well, if we slow the wind down, we won't have the energy to move the soil. And so for that problem, we're going to establish a windbreak at the edge of the leading edge of the field and possibly within the field. And so if you think about the buffer practice, then for the ecological function, well, then how do you design it, which we talked about, is to achieve that thing of slowing the wind down. And then we create a new condition that is the desired condition if everything goes well. And that's our role, is to help work with the landowner to work through that process and understand what are the options to achieving that desired condition. And so the other thing that it's very easy for farmers, producers to think about their field, that small scale. And one other thing that we can bring to the table as the partner with the producer, the farmer, is to think about the context of that area. So if you're using some language from the wildlife biologist, we can think about the matrix. What is the predominant matrix? And Pam mentioned earlier, like the Great Plains. Often we think about a grassland is the majority background of the matrix of the system. Or if you're in South Central Nebraska, it's irrigated crop fields. And then we can talk about what are the corridors, those linear features that connect patches across this matrix, and how those corridors, like our buffer practices, our linear buffer practices like windbreaks, can create connectivity across that landscape. And from a, here's a real life photo. We can talk about the matrix, which is the crop field. And then we can talk about what are the patches that are different than the matrix. So the farmstead or the little wood lot or a piece of pasture that's there rather than just all tilled ground. And then we think about looking at the landscape for the corridors or the buffers, whether it's that stream corridor or it could be a terrace or it could be a grass strip and the corridors. Even the roadway is the type of corridor or the lane. And so how those work together and impact the resource concern is we want to look at that larger context and not confine ourselves to thinking about the windbreak on the site and just the land adjacent to the windbreak. But what is the context? What's going on? Because that wind is coming from someplace and is carrying some qualities from that upwind location, whether it's soil from filled ground or fallow ground or wind or snow from a parking lot. It's carrying some qualities from upwind onto the site that we're actually concerned about. So we do have to step back and look at that context a little bit. And then how well the buffer is going to function is impacted by the location on the slope. Is it on the top of a hill, the bottom of a hill? Is it upwind, downwind? The design dimensions that we just talked about, the composition of structure vertically and horizontally in the species, and then how that changes through time, not just in a growing season, but throughout the lifespan of that practice, that buffer, or in our case, windbreaks. And ultimately, though, we all recognize that how well that buffer is going to function begins with the design, but it's a function of the commitment, the equipment, the goals of the farmer, the producer, to achieve that desired condition and maintain the buffer and the function that we worked with them to design. But we have to start with a good design that addresses the identified resource concern. And sometimes identifying that resource concern is a little bit of 20 questions with the producer to really get at the issue, because we may think of these as business decisions, that it's pretty straightforward. You know, you're trying to protect livestock, and because livestock, that's both your manufacturing plant as well as your product or the soil or the crop. But we're really talking about something that's very near and dear to their heart, and it's a part of who they are as a farmer or a rancher. And people just don't expose their inner feelings and goals and desires that easily. So we have to be willing to listen. And there's a whole raft of information we can talk about on how to communicate and listen to hear what are the felt needs, not just the superficial needs that we're talking about. And again, these buffers, all these different buffers, including windbreaks, can be designed and work together to achieve a variety of new desired conditions. And we want to do that in an efficient manner. And so going back to our windbreak standard, the 380 standard, if you read that, here are the supported windbreak purposes that this practice can be used to address, and particularly if we're using time of our staff to work with the producer or funds from conservation programs to help establish a windbreak. And that's a lot to cover. And so for the purposes of this presentation, I've tried to break it down a little bit to these topics. So field windbreaks that are affecting soil and crop, protection of livestock structures and people, because those end up using a fairly similar design. Snow management, which is much more complicated than you think it might be from the onset, and we just can't get into all the nuances. And then some of these other issues that are listed as potential purposes for windbreaks, and that have some different contexts that we need to be aware of, and how the windbreak design can be altered to achieve those windbreak purposes. So that's the direction we're going right there. So start off the field windbreak, which I think has fallen out of favor, to be honest with you, with many producers. The classic single row field windbreaks and some of the pictures that Bruce showed, and these great aerial or oblique aerial photos we see of one windbreak after another across the landscape. Boy, you just don't see many of those planted. We'll see some on the edge of the field, but not really in field. And when we talk about conservation practices, we to really achieve the benefits we're talking about of water quality and wildlife habitat and air quality, we'd have to have in-field and edge of field practices. So here we are, field windbreak. And so we're going to look to, again, the height of a field windbreak, and because that's going to impact, it's the kind of an efficiency function of how much area downwind from the windbreak is going to be protected. And that's, as we talked about, a very strong correlation to the height of the windbreak. So we're going to choose a species that at least one row within the windbreak is going to be maybe as tall as we want to get, but also we need to provide that moderate density, 40 to 60% dense. And you'll ask, so how do I achieve that if aerodynamic density and optical density aren't the same? And I think we'll get to that here. I've got a couple of slides. And recognize the time of year. So a single row of green ash in the winter, leaf off, is only around 25 to 35% dense, depending how closely the trees are spaced. And that's another way to impact density. But with leaf on, it's more like 40%, maybe it won't reach 60% density, but 40 to 50% density in a single row of, say, green ash. And of course, green ash under attack by emerald ash borer. So we have to find maybe a plant that's comparable. And again, looking at the soil, the species that'll grow on that site and achieve that height. So let's see here. The width and the length, again, we're going to have that minimum width is 10 times the minimum length is 10 times the height of that windbreak, and it's going to be at least as wide as the thing we're trying to protect. And again, thinking about the relative height of the windbreak to the thing we're trying to protect. If it's soil, then it's the height of the trees. If it's livestock, we want to think about, well, are we talking about poultry? We're talking about cows. Thankfully, we don't have to worry about such things as giraffes in Nebraska. That would be a really tall windbreak. Or are we trying to protect a house or a barn, a milking barn, something like that, or a greenhouse that needs to be protected, or a hoop house needs to be protected. So we might make sure again, the height of that, the species that are chosen will protect the thing that we most want to protect. And the idea here, particularly when we're protecting soil and crops and field windbreaks, is we're going to choose, we want to have the windbreak take up the smallest area in the field as possible. That's just from economics, because the windbreak, if we're choosing species that are not going to yield us a crop of any kind, then that's land out of production. And a fair amount of the research suggests that around 5% of the field can be taken out of production in well-designed windbreaks and still be economically viable because of the enhanced crop yield on the downwind side of the windbreak. And I talked to Jim Brandl, who did a career worth of research on windbreak function and windbreak design. And he told me that if you go anything past 3 rows wide of trees, looking at average spacing, 12, 15 feet between rows, he said, your economics is going to start to fall apart. You have just too much land out of production. So we're going to look at 1 to maximum 3 rows that will achieve the density that we need for that windbreak. If we're talking about protecting crops or protecting soil. And again, which time of year are we looking to protect? Is it when the soil is bare in the spring, if this is just continually cropped site, or is it a particular crop species that's sensitive that we want to protect when it's emerging? And that might be different if it's winter wheat versus when it's corn or soybeans, say. And so we want to be concerned about, again, the orientation and location of that windbreak. And what are some of the limitations? Obviously, trees need to grow. They need time to grow. And if you read that conservation practice standard, it says, until the windbreak achieves adequate height and density, supplemental erosion protection may be needed, such as, and it mentions conservation tillage to leave residue on the field. And, you know, Bruce mentioned, but some years are dry and you don't get much vegetative matter to leave on the field. And so these images suggest that when the windbreak and the top image was initially planted, there were also established a series of vegetative wind barriers, grass strips on that field. And then as the windbreak is taller, you can start removing those grass strips because the windbreak is now providing that protection. It looks good on paper. I'll be honest with you, I have never seen this done. And I would be curious if anybody has actually ever seen this done with the grass strips, but that's the concept. Or it could be some other conservation practices until the windbreak is providing the design or purpose for the windbreak. So there's some limitations to think about. The other thing is, as much as we like this nice uniform windbreak of this one species on this full length of the windbreak, soils just aren't that uniform as a rule on the landscape. And you may likely have to change species as you move down the length of that windbreak. And yes, a lot of our farmers and producers, they like uniformity. They like the same look. You know, that's why hybrid crops are so popular. I mean, you look across the field and every plant looks just like the last one. And windbreaks aren't that way. Even if you were planting all of one species, not every tree is the same. But if you start varying the species down the length of the windbreak, it loses a certain type of aesthetic for some people and maybe gains an aesthetic for other people. So recognizing that just because you start with green ash always comes to mind, but help me out, say a hybrid poplar, as you move across the field, you may have to change to another species because of soil changes. And that's part of your assistance provides the landowner looking at soils map and interpretation. So another tool that you can use is the wind erosion prediction system, WEPS, and there's a web link to that. It's a technical tool to look at soils that, and you can put it, you look at the local information, the types of soil, the types of farming practices and conservation practices, and it will help provide information on design of conservation practices to control the wind erosion of those soils when you have wind erodible type soils. And here they have some drop down menus on that. And this is what I was mentioning earlier. So to give you some idea of a single row evergreen at that 25-foot height, one row, 10-foot apart, is a porosity, notice it says porosity of 40%, which means its density is 60%. Whereas trees, one row leaf on might be 40% porosity, that translates to 60% density, but leaf off, whereas one row is about 60% porous or only 40% dense. I think that's maybe a little judicious, but they also have a similar drop down on relative porosity or density of some shrubs. You can see different leaf on, leaf off, number of multiple rows, and then even for herbaceous barriers. And it also has in that data set looking at orchards and the impact of different types of orchards, leaf on, leaf off. So that information is what helps support that WEPS tool. And it is just that, a tool. It's not going to give you the answer, but it's a tool to use with your experience, with the producer's experience, to come together to come up with a plan. And so that's a tool at your disposal. Livestock protection. So the livestock have certain needs, producers have needs in relating to managing their livestock. Heat loss and heat stress. So cold and heat are going to be some of the big things. Access to water feed, and of course, drifting snow in our part of the world is a big issue. And trust me, we can put drifts of snow where you don't want them if you locate that windbreak in an inappropriate location. And to achieve these, we're in Nebraska, like that video that we started with, we're usually talking about protecting livestock under cold conditions or winter conditions. And So there's been a fair amount of research. This table talks about the percent increase of calories needed to maintain different animal weights, and they list the critical temperatures of a summer coat on the livestock. This is cattle, fall coat, winter coat, or heavy winter coat, and the animal's weight, and then the change in energy requirements, feed requirements, that's money, to maintain body condition. And so that's a good reference. There's also, here's your wind chill chart, and looking at where you need to start being concerned. And what I find interesting about this particular table is the little danger to mature, let's say zone 2, and that at say 10 degrees, wind speeds of 25 miles an hour, we need to really be concerned about the stress on the livestock. So if we can reduce wind speed, remember, just the exchange or the loss of heat from that animal as the wind interacts with the surface of the animal. We can reduce that wind speed, we can reduce heat loss. And so we think about a much more dense windbreak requirement than we have for soil protection or crop protection. And so we're looking at as dense as we can get, and they're usually 60 to 80% dense. And I talked again to Jim Brandel, and he said, 85% dense is about as dense as we can get a windbreak. That's multiple rows of evergreen, like eastern red cedar and pine and maybe arborvitae. He said, we can't get 100% dense windbreak. This air will end up working its way through. We can't make it 100% dense, like a solid barrier. But we want it as dense as possible. And really to get that kind of density, we're talking about a minimum of usually 3 rows. Often we see 5 rows, because when we make that dense windbreak, we're also going to be creating snow drifts. And by having multiple rows windbreaks, we create snow storage within the windbreak, as well as on the, we have to allow for snow drifts on the downwind side of that windbreak. Oftentimes, one way to treat some density is remembering, we'll get into this with snow, but most of the blowing snow is close to the ground. So shrubs often work very well in helping to create that lower density within the windbreak. And the spacing between the rows, we can talk about with respect to, for the tree species, look at how wide the crown is, but more critical is the spacing between the rows, is what equipment is the producer using to maintain that windbreak, particularly in its early stages, for controlling the weeds that we talked about. Is it just the one big farm tractor? Do they have some other smaller equipment? And that access between the rows and allowing for some growth of the crown, but still be able to get the equipment through without breaking branches. That's really the important spacing between the rows. And as much as we might say, if you had more space between the rows, it's more snow storage. Space is land, land costs money. And so there is that dynamic trade-off between how much space to allow for the windbreak and how wide you can make the rows, the space between the rows. And you can, to some extent, tighten up the spacing in the row to compensate for the density of the number of rows. But again, that creates a different competition down the rows as trees get older, and competition for water and space, rooting space and sunlight. So closer spacing creates greater density, more rows creates greater density up to a point, and that the area of maximum protection is 2 to 5H. And so if we're talking about calving, you want to make sure that we can dump snow, but have some of that area still free of snow for the greatest amount of protection. And that can be, there's a fine line in there, because that a lot of that snow, when we'll get into snow management, you'll see some diagrams of how far downwind snow will drift. And so a secondary windbreak or a short row of shrubs to the outside of that main windbreak can help dump some of that snow initially, but it's creates some complication of the management of that land outside that windbreak if you have just a single or double row of shrubs that are spaced 50 feet away. That's just an odd design. And the other thing I should mention on spacing is if you're having an L-shaped design like in this picture, how to design that so that it's more easily for the tractor to move from going north and south to east and west. And whether you do it like this continuous curve on this windbreak is one way to do it if you have nice wide curves. Or there are other ways to do it, but think about navigating once you're in the windbreak as the trees get older with the maintenance equipment. We have a minimum 1 row of conifer is in the standard. If you're fencing to protect it from livestock, make sure it's far enough away from the trees that it doesn't get broken down by snowdrifts. And you want that windbreak to be at least, we recommend 100 feet past either end of the area to be protected. Consider multiple legs on a windbreak, whether it's an L or U shape. Those are some of the things for livestock protection and density. And I think one of the, I'll get into it. Outdoor living barns is another way to put some livestock protection out further away from the headquarters, where livestock may be and maybe caught off guard. And dense windbreaks usually have at least 2 legs of a windbreak. I've seen them in the shape of a letter E. So it creates multiple areas of protection and possibly fencing all the way around so that if the wind shifts, because often as our storms come through, winter storms come through, we'll get the northwest wind, but as the storm passes, we pick up that southeast wind. And so if you can have access to all sides of a living barn, you're more likely to have livestock to get protection throughout that duration of that storm. And then we mentioned different lengths of windbreak. I think the other thing I was going to mention before we move on to snow is that if you're protecting a feedlot area, livestock area, or about any other place, think about what happens and where the snow melt will run. If it's just going to flow into that feedlot and create a mud pile, that's a whole nother set of problems you've just created for the producer. Or if it's going to run off across an access lane, a critical access lane. So think about where that water is going to go when the snow melts, and you may have to put up some other sort of practices or earth shaping a berm or a drainage swale to redirect that snow melt once you've created a pile of snow. So you have to think about throughout the growing season and the impact of piling up snow and where it's going to go. Windbreaks and snow management. So we often think of living snow fences. I think Craig mentioned that, you know, they had a living snow fence program that went on at the same time as CRP and continuous sign up kicked in. Nebraska has had a living snow fence program from time to time. I think Washington State currently has a program to emphasize living snow fence. Minnesota has been supporting living snow fences for a long time, and they've got some online tools for designing living snow fences, mostly in conjunction with their state highway department. And the reason we think about managing snow because snow can save lives, as good snow management can save lives and save money, not just on the clearing of roads either. And so we think about snow, it's snow storage is the important thing. And this graph, I think is rather interesting. And the green vertical bar is the height of the barrier. And then the purple is the tons of snow stored, so just quantity of snow. And notice that with just a little bit of increase in windbreak height, we have significant amount of snow storage increase. In other words, one fairly tall living snow fence or windbreak to stop snow can store more snow than 2 shorter windbreaks. And so that's important to know because again, land or space is money. And producers aren't going to give up so much land for windbreaks. And so we need to be aware that if you only got so much space, make it as tall as possible in the right location. And so thinking about designing a windbreak for snow, here are 2 designs. The top diagram is a very solid barrier. And you can see the pale blue there is the profile of the snowdrift. And you'll notice that there's snow drifted on the upwind side, as well as the downwind side, or the windward and the leeward side. And out to 10/8 you can get some snow drift, but the predominant drift of snow is inside of 5/8, 5 times the height of that wind barrier. And if you have a more porous windbreak, you can actually store more snow. But notice that snow print, if you will, footprint of snow can extend out 20 times the height of the windbreak. And because that wind continues to push the snow downwind, because the more porous windbreak. And so we can manage snow. Often we just think about making snow drifts, but we can also think about spreading snow across the field. I got this from Craig Stange. I'm not sure who he stole it from. I think who knows, he may have created it. But just to give you an idea that snow drifting into windbreak. So our wind is from left to right. You can see the 0, 3, 15, 20H across the bottom, and the green tree, of course, is our windbreak. And here is initially the way the snow will drift, a little bit on the upwind side, a little bit more on the downwind side. And as we continue to have either a big storm or subsequent storms, that snow drift gets bigger, larger and larger on the downwind side. And this is, we all go, well, that looks very familiar. And that continues to pile up and getting deeper, and not much addition to the upwind side of the trees. And then gets even, but you notice now it's just not getting that much deeper. You're not storing that much more snow. A lot of that snow is blowing on past now. And then that fifth, and I'll just do a sixth, and you notice out to 20H. And then at some point, the form and shape of that snowdrift is almost invisible to wind, and we reach equilibrium, and it's no longer storing more snow. And so what we want to do is trying to capture as much snow as possible, recognizing that, are we designing for the worst case scenario, or are we designing for the most common scenario that the producer is trying to manage for? And which one is can they afford the cost of snow removal and livestock feed and that sort of thing of a moderate storm, but what they're really concerned about is one of these big major storms, or that when we get into that sequence where every 7 days we're getting another snowstorm. So depending on if we're designing for the worst case scenario to protect the road or a livestock feeding area, or just every single storm that comes along, will dictate the size of the windbreak and how many rows and how much snow storage we're going to design for. So here's a picture. So the barrier, the tree planting, is the gold line on the left. The wind's coming from the left. And this was a little research project, and I don't know who did this. Again, I stole this from Craig Stange, this picture. And you can see that part of the windbreak was unpruned, and then they pruned a section, then they didn't prune a section, then they pruned a section. And notice in the green arrows pointing to the areas where they pruned the bottom side of the trees to allow that wind to blow underneath the trees, that ground is almost bare, and it pushed snow quite a ways downwind. But where the trees were unpruned, a little more density down close to the ground, you can see that there's that the snow distribution, it doesn't push as far downwind, but there is snow piled up right next to the windbreak as well. So these are some management techniques if a producer is willing to put in the time to do management techniques. And my experience, and most of our producers prefer to plant a windbreak and walk away from it rather than doing ongoing management of our windbreaks. And maybe that's an educational process, another process we need to be spending some time and emphasizing with the producers, that just like the intensity they manage their crop fields and soils and livestock, that these windbreaks need attention as well throughout the lifespan of the windbreak to help provide the intended purpose for as many years as possible. So you can think about windbreaks can also, as we talked about, dumping snow or collecting snow, collecting it for to collect water for a livestock watering bank. We could design it that way as well, not just for protection of the animal itself, but maybe collecting snow or protecting a road, but collecting snow. So some issues: you want that windbreak to be as perpendicular to the troublesome wind as possible. For snow distribution, we're thinking 25 to 50% dense. For snow accumulation, we're thinking maximum density with a minimum of 50%. We want that windbreak to extend beyond the area that's being protected so we don't get wind drifts, the snow drifts wrapping around the end of the windbreak, particularly when we talk about roadways and access lanes. And think about where that snow belt is going to run off, which direction it's going to go, and what we can do to manipulate that. And then we want to avoid shading on public roads. And I drove across a number of roads here after that last storm back around Thanksgiving, again and Christmas. Should have stopped and taken some pictures, because some of those roads, even gravel roads on the north side of a windbreak, a farmstead windbreak, they can be pretty treacherous. So we have to think about not just the downwind side, but what's happening on the upwind side as well. And when it gets into snow management and along roadways, the road ditch or a road cut, that topography, all that affects how the wind blows and the snow collects. And talking with the producer, where does the snow accumulate? And if it's up against a neighbor's property, what type of land management does that neighbor have? Is it always soybeans, or is it always in pasture? Do they hay it? That'll affect how much snow is blowing across that property that we now have to manage. So, and some of the issues that can create problems that I mentioned, topography, like road cuts or hills or valleys, the vegetation on the upwind area, and guardrails, and again, a location of like existing structures and how that wind will interact with the snow. I wish we could spend more time on snow management. It can get a lot of it depends sort of answers. But once you start thinking about the dynamics and paying attention to what you see on the landscape, you can work, and what the landowner producer sees on their landscape, you can come up with a pretty good design for that. Changing topics, odor, chemical drift, odor. This topic has become more and more of a concern because we have more and more confined animal feeding operations. And when you put that many of anything together, I don't care if it's people or animals, and that waste is going to accumulate, and you got to do something with it, and it can create some pretty strong odor. And the way people are moving out onto the non-farming people are moving out onto the landscape, and it become conflict. And so people have looked at, can windbreaks be designed to have a positive effect on this and help manage this? And there's so much research being done on livestock odor and back to what they're fed and how that waste is managed. But basically the things that a windbreak can do, if we think about windbreaks again, affecting airflow, is possible dilution of the odor plume that is mixing it up so it dilutes it as we create turbulence, or deposition of the dust particles and aerosols that are being carried about in the wind, and then maybe even interception on the plant material itself. And trying to think of these windbreaks, wind barriers, as a sink to collect those odor carrying particles, particulates that's in the air. So here's a diagram of a wind barrier, fairly dense on the upwind side, and it creates, there's a quiet zone, but then it creates turbulence higher above, and there's the odors, and it mixes, and then we have a windbreak on the downwind side to try and trap some of maybe particulates and things. It's not as simple as that. It's not 100%, and the research is still coming in about how effective windbreaks can be on odor control. Some of the research being done, I was seeing out of Maryland in that area, was looking at poultry houses where they have the forced air systems, and they have a quiet zone, and these forced air systems have those circular vents that are drawing air through the structure and then blowing that air right onto a windbreak, and so that it's controlling the odor and directing the odor and the particulate carrying the odor right into the windbreak. In other words, taking control of the situation. I know that those things are created for ventilation, but the location of the windbreak is to receive that ventilated air and can trap particulate. But that is not without cost, because all that particulate, it accumulates, some of it clings and accumulates on the surface of the plants. And you've seen this maybe on dusty roads, that the plum, the choke cherry, and the road ditches are just coated with dust. Well, you know that plant is not producing as much sugar when photosynthesis, when the surface of the leaf is coated. And so, you know, how do you manage that? Do you have a sprinkler system that washes that off down to the ground, just like you wash out maybe a reusable air filter on your furnace? You wash a particulate off to refresh the filter. That's one way. But if you don't do anything, that's going to be very detrimental to that plant. But the dust particles and the ammonia can be reduced. This is Leyland cypress that, again, it was research done out east. Maybe 30% of the dust can be trapped in 18% of the ammonia. And again, notice those aren't 80% and 100%. That's just some management of the odor. There is some research out there that suggests, it came out of Iowa State, that by a visual screen around these feeding facilities, these concentrated feeding facilities, that the perception by the general public going by is that there is not as much odor. But that's just a perception, because they probably aren't seeing the facility, or they recognize that the facility is trying to control the odor. But frankly, I don't know how long that'll last if the odor gets quite strong and on a regular basis. And also think about who is receiving the odor. Which wind direction is most critical? Is the neighboring town or neighbor housing development, you know, upwind of most of the time, or is it downwind? Think about troublesome wind directions and where is that odor going? Visual screens aren't something we cost share about. We can think about visual screens. They're just, you know, think about, again, the height of the windbreak to obstruct the view that we're trying to hide. And it may be privacy. It's not that we're hiding anything, it's just privacy. So you can have these straight engineered, as Pam says, engineered, you know, north, south, east, west, square corners. Or you can make it curvilinear to make it a little more aesthetic, as long as we're talking about visual screens and aesthetics. And then you can add accents maybe to the corners and little clump plantings just to make it a little more attractive. And here's something that's really gone off the rails with the curvilinear and clump plantings and things. And you can start talking about color at different times of the year, of different parts of the plant and different times of the year, and the texture, and creating visual attractiveness. And at this point, as a forester, I'm getting very uncomfortable talking about these sorts of aesthetics things. And don't ask me how to match the drapes with carpet. I have no idea. But and then just the overall form. But aesthetic is an important thing, because this is where your producer farmer lives, works, and plays a lot of time is there. And so there may be a negative perception about this arrangement here. So you can just plant a straight row of some dense, you know, spruce, block the view, shut up the neighbors. Or you can do something a little more extensive and add some other visual quality to it and demonstrate that you are also concerned about, you know, the public opinion and public appearance. So aesthetics is important. And again, I mentioned earlier, sometimes uniformity is an aesthetic. Sometimes for other people, it's diversity is the aesthetic they like.
Say, Rich.
Yes.
You got about 3 minutes.
I got about 3 minutes left. Thank you. Appreciate the heads up. So noise is one, but I sure wish we could do more about noise, but frankly, we can't. Road noise is often the big noise issue that we talk about, and mechanical noise. And a couple of key things about noise: it's density. We have to have it as dense as possible. You want it to be that the barrier visually blocks the entire source of the noise, and that the barrier is located as close to the noise source as possible. When you get high-speed roads, that just isn't very practical, because for safety reasons, they don't want trees very close to the road, so when cars go out of control, they don't run into these big, nasty trees. And we can understand that. And also topography. If you're up above the sound source or down below the sound source because of a hill. And frankly, what the information, a lot of this comes out from highway management, is the most effective part of a windbreak to block noise would be this earth berm. If you create an earth berm and plant vegetation on it, the earth berm actually reflects a fair amount of the sound away from, say, this house, and then a little bit of the sound is absorbed by the plant material, but the majority of the noise reduction is done by the earth berm. Energy, we're talking about dense windbreaks again, and we're talking about reducing wind speed because it's the same thing as wind chill and what's the direction that the wind is coming from. And most of this is due to cold air infiltration. And a lot of the research that's out there, and Craig and I have had these discussions, was done on mobile homes. Well, a lot of the new home construction just doesn't allow for much infiltration. And so I don't know that there's as much energy to gain on housing, but maybe livestock facilities, which are not, more like barns and pole barns and feeding structures, may be more beneficial to control heat loss than for actual residential quarters, because our construction standards are so much better. We don't have that much cold air infiltration. And I think the last topic is going to be wildlife habitat. And again, when somebody says, well, planting trees for wildlife, the next question should be which species of wildlife, because it's not all wildlife respond the same. And then what is the limiting factor for that wildlife? Is it food? Is it winter cover? Is it brood rearing cover? Is it loafing cover? Is it that we need it more dispersed around the landscape? So those are the things you want to be talking about with wildlife habitat. And those get to be very particular questions, but often we're talking about corridors to connect smaller patches to make that patch more functional for the wildlife, or visual screens with the wildlife who are more comfortable to move across the landscape. We want to use probably more likely native species that provide multiple purposes, visual screen or food sources or nest cover. Pollinators, this is a big issue with pollinators. We know that bees not only forage further away from a windbreak or further into the field, but they're more effective, more efficient at pollination when we have wind speed reduction. And so those are some of the issues you can take into consideration. So there are many things that a windbreak can do, but one windbreak can't do them all. And it takes that cooperation between you and the producer to consider what are the issues, what are they trying to address, and then what are the qualities that we can design into the windbreak. And usually that, think about low, medium, and high density, not specific percentage densities for our windbreak design. And that's it.
All right, thanks, Rich. We had a comment from Liz Mars, and good to see you. Good to see you made it, Liz. Liz is from North Dakota.
You gonna read it to me, or do I have to find it?
It's an aha moment for them. They think trees will grow anywhere and are significantly different from any commodity crop, but then when discussions will lead into limiting factors such as soil and moisture, they begin to view them as similars.
Yeah, right. And I think that's important, that they need to be managed like any other crop, any other part of the farm operation is recognized. These are living things that have specific requirements. And so Liz, you have another question? I see a hand
Liz,
up.
go ahead. You can unmute.
Sorry about that, guys. I was pushing buttons. Yeah, no, it just had to come into, with the snow deposition and other things, and the management. Rich, when you were talking about, getting these landowners to realize that they need to manage it and not just plant them and walk away, which happens so often. The conversations that go to that path are more common than not. But I guess I have turned up in this area, I have turned to relating it to crops, and you start to speak commodity crops, which they're very, familiarized with, and compare trees to it. It begins to, it's an aha moment. And I think it plants that seed of, okay, well then what management techniques do I have to look into, for my trees, for my planting?
Yeah, and we haven't begun to get into such things as, maybe annual inspection at certain times of the year for the most common insect or disease problems for the species that we've selected, and just, walk through and pay attention to the windbreak for a change rather than everything else. And yeah, as you said, Liz, treat it like a crop that needs some attention at maybe specific times of the year, not continuous attention. It's not that intense, but yeah, it's a good point. Thanks for bringing that up.
Got a comment for you, Rich.
Yeah, correct.
Greg. On the design for many of our conservation practices, predominant condition or average works quite well. But on a windbreak, I think back to the 96, 97 blizzard, we had 8 of them in North Dakota, lost 130,000 head of cattle. Some guys went out of business, generations of farming gone. And in many cases, all it might have needed was another row, a little bit farther setback, and that's all you would have needed to handle the really adverse condition. Living snow fences, we have all kinds of orange equipment for average.
Yeah.
We have a contract for the dozers on the really, really bad one.
Yeah. And it's sort of like insurance. You can invest upfront with that extra windbreak for the extreme condition, knowing that you're covered in the average condition. But what is the cost of the extreme storm? And if you say it's not that bad at the worst case scenario, then don't plan for the worst case. But if the worst case scenario is a livelihood, then the investment up front in a little bit wider windbreak, more extensive system it's a good economic decision. So good point, Craig. Thanks.
All right, we'll take one more question, and that's from Rich Nelson. Rich, you want to go ahead?
Sure. Thank you, Pam. Just a quick comment and a question, Rich. My question, I'll say them both and I'll let you deal with the fallout. But the question is, I know that we can measure a lot of things that you've covered, decibels, of noise or snow. Is there a means to measure odor? I mean, I realize there's maybe some ammonia content just to determine effectiveness as opposed to just human perception. And then my comment was kind of related to your last thing where you briefly touched on, the interest in pollinators now. And not only does foraging downwind, because wind can affect those species as they're foraging, those insect species, but also we use it a lot to try to prevent pesticide drift into those areas where those pollinating insects may be feeding. So I'll shut up now and let you go.
Thanks, Rich. Good to hear your voice. Yeah, the pollinators are really interesting ones. There's some research being done right now, a variety of places, but at UNL as well, and Gary Bentrip in our office. And looking at, there are concerns about pesticides and their impact on bees. And if we have an area that we're trying to protect where we know the bees are going to be active, then on the suggestion is flowers actually accumulate, because the nature of stamens and pollen accumulate particles that carry pesticide. And so we can actually unintentionally concentrate pesticide on a flower where we're attracting a bee. And and there are situations that have been well documented where just serious bee die-off because of that. So if we have maybe the edge of a field, we won't plant any flowering plants to intercept oncoming pesticide. And then on the interior of the field, maybe that's where we'll put flowering plants like willows, which flower very early, and some other plants that the bees can use throughout the growing season. So that's an important distinction to make, is that it can be a barrier that trap the particles carrying the pesticide, and the interior field windbreaks can be a source of pollen and food for the foraging bees as well. So yeah, it's depending what function we're trying to provide and what part of the field. The other question was on measuring air quality. I don't think there's a convenient, easy way of common piece of equipment like an anemometer, go out and measure wind speed. I don't think we have too many things like that to measure air quality, like the amount of ammonia or odor or particulate. I'd have to look more into that to see if there is anything that maybe like a regional office or an area office of an NRCS could have. But researchers have it. I just don't know if there's anything practical for us in the field to use. But it's a good question. Maybe worth looking into, Rich. I just don't have a good answer for that.
Yep. Thanks for your comments on both of us.
Yeah. Pam, I guess it's back to you. Did we lose Pam?
We might have.
So Ben, it's back to you.
It's back to me then. Okay, well, let's consult the agenda here and see. I think Pam was up next to present, wasn't she? Well, how about we do this? Let's take a 5-minute break, and then I'll give Pam the chance to hop back on. And let's plan on all jumping back on here at about 3:55. That works for everybody?
Sounds good. Thank you, Ben.
All right, everyone. Well, I just heard from Pam, and it sounds like her internet has gone down, but I guess the show goes on. Actually, up next, we are going to have Lord. And Lord, this is funny because Pam and I were debating on how to pronounce your last name, so you're gonna have to clarify which one of us was right there.
Okay. Okay.
Could you,
Amael,
Emil? Okay.
did you
So
win?
yep, you got it. So you, Lord is the National Technical Assistance Agroforester for the Nebraska Forest Service and the United States Forest Service. He's going to tell us a little bit about international agroforestry and windbreaks. So Lord, the floor is yours.
Okay. Share my screen here. Okay. Can you guys hear me?
Yep, and it looks good.
Okay. All right. Awesome. Thanks for this invitation. As Ben started off with, my name is Lord Amael. You made my position sound way too complicated. I'll just go with a simple one so that I don't get anybody, I don't lose anybody. My name is Lord Amael. I'm an agroforester. I get to work in that capacity as an agroforester with the Nebraska Forest Service and the University of Nebraska-Lincoln. I think it's been since July 2019. Now, I also support the work of the National Agroforestry Center here in Lincoln, and I actually work a lot with Rich Strait. You know, for this talk, I'll put on my Nebraska Forest Service badge, permits me to do that. I'm going to talk a little more agroforestry and specifically windbreaks, since that's what this training is all about. But I'll try to give it an international spice. Now, Bruce and Rich have looked at some of the technical aspects of it. So, you know, I'm sure you're all a little burned out at this point. So mine is going to be fairly short and it will be easy on your mind, I promise as well. Then Ben, you have to forgive me if I put us way ahead of schedule.
Oh, you're fine, Lord. We're pretty flexible right now.
Okay. All right, so as I mentioned already, Bruce and Rich have already said a lot about definitions and meanings of agroforestry, so I'm not going to bore you with the same info. I just wanted to point out some of the benefits of agroforestry just to lay a foundation for the rest of my talk. Now, what we know is that agroforestry is basically a marriage between agriculture and forestry. So in my own personal view, I see it more as and I think some people are going to slam me for this, but I'll say it anyways. I see it as a land optimization technique or strategy, basically to merge the benefits of the two land use types. So I also, most importantly, want us to note that this marriage that I'm talking about between agriculture and forestry does not mean a conversion from agricultural lands to forest, at least in the case of temperate agroforestry. I also want us to know that agroforestry is a whole lot more in terms of benefits. We looked at a couple of those here. I didn't talk about it, but you know, we've talked a lot about benefits of agroforestry in general already, so I didn't want to go through it. But there's a lot of benefits that we can get from agroforestry systems, and compared to agricultural systems, which focus mostly on crop production, in an agroforestry system, we have more diverse or several benefits. And you know, it can range from just carbon sequestration benefits to income diversification, since you have a lot of components that you are looking at in that system. Then we can also talk about just water quality protection. You can talk about some crop production as well, then some risk reduction when it comes to weather or extreme weather events. Now, I just wanted to also mention that agroforestry is a whole lot more than just those benefits that I talked about. You know, if you're talking about agroforestry, you're talking about sustainability, and that is the ultimate goal of agroforestry in general. So, you know, we can talk about, of course, profitability, talk about innovations, talk about livelihoods, education. It's all worked into agroforestry, and if you have all those coming together perfectly, then we get to that sweet spot of sustainability that we all seek to get to. So we get our sustainable development as well as our sustainable agriculture. Okay, so I really like this figure so much, and I'm sure some of you may have seen it already. It shows a very fluid continuum among the major components of an agro ecosystem. I'm talking about trees and crops and livestock. Now, within this framework, the 5 popular practices in the United States are shown. And I'm not really going to go through all of them, but you know, what I wanted to point out here is that the indefinite possible combinations of the components also leaves room for a lot of variation in practices, even within the United States itself. So this means that even though the foundational science of agroforestry is same everywhere, its manifestation on the land is actually location specific. And I believe that's why even when you go to the NRCS side of things, they make it flexible for states to adjust practices to suit their specific needs or natural resource concerns they want to address. Okay, now we'll look briefly at some temperate agroforestry systems. I just want us to go to the tropical side also and look at how it manifests. Now, those variations that I was talking about among agroforestry practices in the tropics are a little bit complex, I should say. Now, I believe this is the reason why there has been several attempts to classify them under some form of categories. So they categorize under functionality, that is whether the practice is for protection or production or both. And then we also have socioeconomic basis or standard of the practice that can be used where we basically group practices on management intensity or level of input. Then of course, we can also have that big divide between the temperate and the tropical locations as well. Then the most popular among these categories, however, is the structural basis, which gets down to those three components that I showed earlier. So for an silviculture system, you will have only your crops and your trees in a system or on your land. Then for a silvopastoral system like our silvopasture, you will have a mix of pasture, animals, and trees. The last category is agro-silvopastoral, which incorporates crops and pasture and animals and trees on the same piece of land. Okay, there we have it. Okay, so here are I'm going to give some examples of some specific agroforestry practices under those 3 structural categories that I mentioned. So under agri-silviculture, we have it manifests in systems or practices like improved fallow, which is some form of crop rotation. Then we also have a tonja, which is a system whereby where rural communities close to degraded forests are given portions of a degraded land to plant trees and agricultural crops at the same time. Now, upon canopy closure, they are moved to other areas with a promise that, you know, when the trees they planted are harvested, some of the proceeds will come to them. So there is even a modified Tunja system which strengthens the benefit sharing bit of it a little bit more. It is geared more toward restoring degraded forest lands. Now, that's a younger version of me in one of the Tunja systems in Ghana. We're incorporating mahogany and soybean over there. Then we already know about alley cropping. We have protein banks, forgive me. We have our windbreaks and shelter belts under that category. Then we already know about alley cropping for temperate system here. So the next system, which is the silvopastoral system, some examples are protein banks and there's plantation crops that are mixed with pasture and animals. Then for agro-silvopastoral, we have some examples as home gardens. And this is a nice picture I took when I was collecting data for my dissertation in Ghana of a home garden. And you can spend a lot of time just talking about this system. Then another example I'll give here is apiculture, which I call it playing with the bees. And lastly, aquaforestry, which is just as it says, having fish ponds surrounded by trees and crops. And these fall under agro-silvopastoral. All right, these are some bonus pictures of cocoa agroforestry to illustrate silviculture in Ghana. Now, some know it as cacao, it's the same thing. Basically, if you look carefully, you might see someone who looks like me in there somewhere. Now, cocoa is shade loving, which is grown together with agricultural crops on the same piece of land. And for the chocolate lovers, you should know that Ghana is the second largest cocoa producing nation in the world. I think the last record that I checked recently says that it accounts for close to 8% of GDP and represents about 20% of total export earnings. So as I said, if you're a chocolate fan, these are some facts that you need to know. Okay, so I have my kids in the background. Hopefully you're not getting any feed. Yeah. Okay, so since we are looking at things from the international side, I was very happy when I saw this chat just illustrating the very impressive use of agroforestry in Europe alone. We have oak tree agroforest in Spain and Portugal and Italy, and also some reindeer silvopasture in the Scandinavian region. I think I need to take my kids there. We want daddy to show them some reindeer. But in all, more than about 50 million hectares of land is in some form of agroforestry system or practice in Europe, which is pretty impressive. Now, I'm sure that you noticed that whilst Rich, especially was going through his slides, he kept using different terminologies to describe windbreaks and shelter belts. And that is indeed true. I'm sorry, this slide is a bit wordy, but I wanted to show that there are many terms that can be used to identify windbreaks and shelter belts, if you will. And to me, I think this creates a research problem for folks like myself. But agroforestry itself has the same issue with terminologies, and I believe that that's another discussion, lengthy discussion that we can have. But what's important here is that there are several benefits associated with using windbreaks, and some of the common benefits are protection of soil from wind erosion, crop and livestock protection as well. Then there are also less common uses like odor control, as Rich talked about, noise reduction, and even sand dune stabilization, which is linked, of course, to soil erosion and even protection from salt spray in some coastal areas. So what I'll do in the next couple of slides is to just show a few illustrations of windbreaks in action across the world. And if you have any questions, you can let me know in the chat or at the end of the presentation. We learned earlier today from Bruce that, as a matter of fact, that the actual windbreaks have been on record since the 1400s in Scotland, which is an interesting fact. So let's start from home. And this is a depiction of the Dust Bowl days of the early 1930s. I think Bruce, again, did justice to this already. So these are just some additional pictures to show that. Now, it is important to know that about 850 million tons of topsoil had blown off because of this phenomenon. Now, okay, just to show that. Then this also is a depiction of windbreaks being used to stabilize sand dunes in Egypt. It's also, it can be used for that. Then this is a picture in Nigeria where I believe these trees were used to protect a school building. I believe this is also from Craig, so probably Hawaii. And I think this is the Glycidia and ironwood that are being used in a windbreak to protect tomato and banana. Then I think in the same region, Hawaii, we have windbreaks being used to protect some homes and people and animals. Then this is a picture of a windbreak being used to improve air quality. Then this is also the only picture I found about the use of windbreaks to control salt spray. That's also another topic that we can look into if there's time, but there's a very nice process about how windbreaks help to do this. But for now, I'll just make mention of that use of it. And I borrowed this from another presentation, which was asking the question if indeed windbreaks could reduce impacts from hurricanes and tsunamis. So since we are all windbreak experts at this point, I just wanted to ask what you all think about this. And you can just put it in the chat or just unmute yourself and maybe talk briefly about it. Any thoughts or ideas? Are you there? Tired? Well, I would say that it all depends, as Rich said earlier on so many things. I mean, you can't have trees withstanding maybe a category 4 or 5 hurricane or tsunami. That's almost impossible. I don't see what tree can survive that force. Now, at lesser speeds, I think it could still prove very useful. And I think it's something that, especially those in the coastal regions, could adopt. Did any? I'm not seeing the chat, so yeah, a second here. I'm not sure if anything came through. Okay. Just go back and get my slides going again. Ben?
Yeah, what are you trying to do, Lord?
Is my screen still being shared using the slides, the PowerPoint slides?
Yep, we can still see it. You're good.
Okay, all right. Turns out I'm not that interested of a speaker because anybody I didn't get any comment from anyone. Anyway,
Well, actually,
okay.
Pam brought up, she said, I think windbreaks might help, and then
Okay.
a few maybes. Here's one from Bethany. It says, I would think the extreme winds could cause damage from flying debris from the shelter belts. That's actually a good point. I didn't think about
Oh,
that.
yeah. That's also a good point. Yeah.
And
Okay.
Bruce says mangrove areas along coasts could help.
Okay. All right. Yeah, it was just something I wanted to throw out there so we could talk a little bit about. Um, I always like my talks to be very interactional. I don't like just going on and talking too much. Is that all, Ben? I can't see the chat, so
So Pam's
yeah.
asking, what about bald cypress for that?
Uh, well, I think it also depends. Um, if you're talking about using that as windbreak to help with tsunamis, and it's still back to what I said. No matter the species, it's going to depend on the category or the speed of the wind. If we're talking category 4, as I said, I don't know which tree can really withstand that force or that speed. Yeah, so it's going to depend. Yeah.
Well, and Pam has a good point. She asks, but would the salt water have an effect on the trees after the water has receded?
Yeah. So and I'll have to like check on this, but I know some trees are very resistant to salt water, and of course, if you are planting something like that, I mean, along the coastal region, you have to consider that in your windbreak design or your shelter belt design. So you can't use any tree at all. So this will go into the planning aspect of it. I know that there are trees that they use specifically for that exercise. And yeah, I could quickly look through my notes. I don't think I can do that right now. But yeah, I hope that answers your question, Sam.
Well, and Rich is adding, there has been some work done to create water breaks to intercept floodwater from rivers, designing them perpendicular to the water flow.
Oh, okay. Yeah. Okay. All right. Just have a couple more slides so we can just go through them. These are some examples of windbreaks being used to protect these buildings and crop fields in China. Then the same also to protect agricultural fields in Denmark. And this is somewhere in the Virgin Islands, I believe, where windbreaks are being used to protect kiwi and papaya. And some in Chile. Then there's also a windbreak in Kansas. To protect some wheat fields. Okay, this is another one from China again. This is the 3 North Shelter Belt program in China. I think the main goal is to use shelter belts to protect agricultural and pastoral land, as well as some human settlements from wind and water erosion. So I think this is my last slide, and Rick talked about this, but I had my slides already, so I couldn't get it out. But I wanted to stroke some thought about windbreaks being used for privacy. What do you think? Not one of the benefits of windbreaks that is very much highlighted, but I think it has a huge usability when it comes to just being used as kind of a privacy lens or barrier for just buildings or projects or anything that anybody wants to be private about? Okay. Yeah, so that's all that I have. If there are any questions, I will take them at this time. I'll stop sharing.
And Lord, to your point about the privacy, Nathan in the chat is saying, you know, we use them for privacy on a regular basis. And Pam added, I think windbreaks could be great for privacy. They're like living barriers that look natural in the landscape. I think that's a good point.
Okay. So I try to look at it from the multifunctional aspect of it. I mean, it could be used for other reasons, including, you know, privacy. I've not heard anybody planting windbreaks exclusively for privacy, but you know, certainly it can be worked among other, among other users.
Say, Lord, this is Pam. Oh,
Hi,
sorry,
Pam.
Rich. I have a question. Do you think that agroforestry in tropical areas is more productive than agroforestry in the temperate area? Meaning what they can produce. I mean, looking at Hawaii, looking at the other areas, they can produce, well, number one to me is cocoa. That's a lifeblood for me, but also coffee too in agroforestry practices. Do you think that's true that agroforestry in tropics is more productive than in the temperate?
I think, well, you do have a point there, and it's a very interesting question you've asked. I think it depends on how you look at it. I mean, we can have agroforestry systems here in the temperate region being designed for productive purposes, and they can yield very substantial benefits. Now, tropical systems, as I tried to point out in my talk, that I think that is the greatest divide between agroforestry practices, that temperate and tropical categorization. So the tropical systems, at least in my experience from Ghana, is designed more to be productive, I should say. Let's talk a little bit about Tonja, for instance. Now, they push it towards productivity for all the components on the land, you know, including the trees that are being planted. So the design is such that, okay, we'll give a farmer or anybody who's interested some piece of land in a degraded forest to go plant your crops. Now, as you're planting your crops, you plant trees on the land as well. So you plant for as long as the trees continue to grow and, you know, the canopy is closed. Of course, when the canopy closes, you can't grow anything beneath it. Then they give you another piece of land to farm on. So the farmer ends up, or whoever does it, ends up getting benefits from selling the crop planted. And later on, when the trees are being harvested, because that's the goal, it's not to just leave that forest, it's for production forestry. So those will also be harvested as well, and the farmer benefits from it. So I think I'll side with you a little bit that the tropical systems are skewed towards more of the productive purposes. Of course, it leaves some green on the land, and this has been used as a reforestation attempt by. Yeah, this has been used as a reforestation strategy by many institutions. Forgive me, please. Give me 1 second. Yeah, I was praying and hoping that was not going to happen, but we can. Yeah. So Pam, I don't know if I addressed your question.
You made some really good points, and don't worry about the kids, Lord. We all, I think those people who do have children know what it's like to have them home on a snow day.
Yeah.
But yeah, you you brought out some good points about keeping green on the land.
Okay.
And Lord, I appreciated your comment that agroforestry in a lot of parts of the world is focused on production. And I think maybe for too long, we in the States have talked about agroforestry from a conservation priority, and that we can utilize the public dollars for the conservation aspects of agroforestry, but we can also modify the design to make them more bent toward productivity, production, diversification of products, and use that as risk management tools of having multiple crops and sources of income and labor management throughout the year. And we just have to get more intentional about that and move away from the strict conservation mindset.
Yeah.
So thanks for bringing that. That was really good.
Yeah, I think when we make it too conservation focused, we scare farmers away from it, because there's that sense that if I'm going to do that, then what am I going to get from it? And of course, we talk about sustainability when we talk about agroforestry. If we hone too much on the conservation aspect of it, I feel like we almost negate the economics of it. Now we are getting into carbon markets and everything, which is still at a very developmental stage. So I don't think a lot of farmers will be interested in the mechanics of that, and just they want some money, they want to see some real cash. And so I think it's good to also promote it from the production perspective, as Rich mentioned. Yeah. Okay, so something here. Has anyone thought about protection from predators, such as thorny shrubs, to deter from livestock? Well, I haven't thought about that one, but it's certainly possible. Depending on where you live, if you have like some big cats or something that can do a lot of damage around there, I think you can use it. But I feel like, okay, it also provides some good hideout for them as well. Anyways, it depends on how you work this out. I think it's also useful. It could be useful for that. Yeah. Okay. Okay. All right. I think, are there any more questions? I don't see any coming.
We did have someone who wanted to know if anyone had experience in silvopasture, especially for heat control in semi-arid areas as a plant conversion. And Rich Straight pointed them out to the Southwest Agroforestry group.
One. Okay. Okay. All right.
Oh, and Liz says, say hi to your kiddos from us.
I'm not going to mention their names right now. If I do that, they'll hear me and they'll come in here. It's going to get more chaotic. Yeah. I will.
All right. Is there any other questions for Lord? Well, Lord, I want to take an opportunity to thank you for introducing us to Agroforestry International. It's really unique. We get kind of hung up in just windbreaks, but it's fun to think about the next time I have a Snickers bar that I could be having agroforestry chocolate.
Yeah. I was teasing, I don't know if it was Rich or someone recently. The person was telling me that he's never taken palm oil before. I was like, do you like chocolate? Like, yeah. Do you like Kit Kat? Yeah. Okay. And you have some palm oil in there. It comes from some agroforestry systems back in Africa. Anyway, that was just a quick.
I never gave it a thought about palm oil. That's interesting.
Okay.
Well, if
right.
there's no more questions, it's 4:30 now, and I know some of you are needing to head off, but join us join us next week. We're going to be back for day 2 of the Windbreak short course. So if you haven't, sign up for it. And everyone have a good night, and we'll talk to you guys later. So hopefully see you guys back here next week.
Thanks, Pam.
Yep, thanks, Rich.